The field that we study is called soft condensed matter or soft matter physics. We're interested in the way the materials around us behave. Things like foams, emulsions, fluids, everything that you might find in drinks.
For me, a good drink or a compelling drink is one that makes a person drinking it say, wow, this is good, and maybe there's something interesting going on. Do you guys have a certain something in mind right out of the gate? You want to...
Looking at the difference between a shaken versus stirred drink?
Great.
That's that.
Yeah, absolutely. Can I use a Manhattan as an example?
Yeah,
I think that's a
perfect.
really good drink for that. All right, so what I'd like to do is just start off with a stirred drink, if that's okay.
It keeps it, in my mind, very smooth, very, very calm. There's no bubbles, there's nothing, it's just completely clear.
So now we'll try the same drink, if that's okay, exactly the same proportions with shaking.
See how much thicker it is? See how opaque it is?
Yeah.
That's because it's filled with bubbles.
And that's just air bubbles.
It's just air bubbles, and you've added the air bubbles by shaking it with the ice. And the shaking effect of the ice has added the air bubbles. Can we taste them?
I would love for you to.
Oh, good.
Down.
That one you can feel the bubbles.
Yeah.
Try this one. You really can feel them on the top of your mouth. Has a completely different texture to it. This is very smooth. You feel the alcohol afterwards, like you said.
Yeah. Really great sort of Swiss absinthe.
That's beautiful.
It's a little cloudy, right?
No, it's perfect.
Yeah. If we pour water through there, it'll sort of percolate down through all this ice, and the water will chill a little bit.
Whoa, look at that. That's so cool. The fact that it went from perfectly clear to something that's very opaque, very whitish, you can't see through it. Because normally if you add water and alcohol, they'll just mix, they'll stay clear. But here there's some oil in it, and the oil comes out of solution and forms these small drops. So it's formed an emulsion. What are we doing? You're doing some foams or emulsions?
Some foams,
or some layers?
Some foams.
Foams.
You guys are happy with some delicious local eggs that I can maybe whip up with some cream and some... All right, great. Well, I'd love to prepare a fun and frothy drink that is famous in New Orleans and getting more famous up here in New England. It's a drink that's called the Ramos Gin Fizz.
So you're adding egg whites?
This is just the white.
The white is where the best surfactant is. Surface active or surfactant, it sits at the surface and it changes the energy or the tension between the two surfaces. It makes it more easy to form surfaces. And it stabilizes the surface. In this case, he's probably stabilizing the surface. It makes the bubble. You see how it holds a hole? There's a hole in the top that just stays there?
Yep.
You can't do that if it's a liquid.
Nope.
It's a solid.
So now
You've made a solid. Whoa, look at that.
We can get a little color.
Oh, that's not a liquid.
Nope.
That's a solid.
One of the ways that I often test myself is to see if it'll hold up the metal spoon. This spoon is actually a straw as well, so it's not too bad.
Cool. What's interesting though is that how can you take a liquid and a gas? A liquid spreads over everything, a gas spreads everywhere,
Yes.
and you end up with a solid. The egg is what's stabilizing.
You can eat it too.
I'm going to taste a little at the top. Look at that. Look at that. It's solid, right? That's a solid. Isn't that cool?